Good morning everyone, I am Mr. Ish. We're looking here at a very quick closing out video here on this topic on inverse hyperbolics, and we'll just look at a few derivative questions and then that'll be it for this inverse hyperbolics. First derivative to find is for this function. We have tan inverse, or you can say inverse hyperbolic tangent of sine x, and you have to find the derivative of this function. You know the derivative of anything which looks like inverse hyperbolic tangent is always 1 over 1 minus x squared, so that's the template we have to follow, and you have to do a substitution technique here because it's a chain rule coming into play. If u is equal to sine x, then function with regards to u is inverse hyperbolic tangent u, and then we bring in the chain rule d over du. You can say inverse hyperbolic tan u and then du over dx sine x, and it's easy. Derivative of sine x is just cosine x. The derivative of tan hyperbolic inverse is 1 over 1 minus x squared, except we're looking here with regards to u, so it'll be 1 over 1. It'll be cosine x over 1 minus u squared. You have to resubstitute the u over here with the sine x, and you have cosine x over 1 minus sine square x. This right here is a Pythagorean identity. Sine square x plus cosine square x equals 1. Cosine square x equals 1 minus sine square x. We're looking at cosine x over cosine square x. You can simplify this to 1 over cosine x, which simplifies at the very end to secant x, and that right there is our derivative for this function right here. This will be an interesting one, inverse hyperbolic tangent of root x. Again, this is the template for inverse hyperbolic tangent, the derivative of that, and we have a chain rule coming in here. If u is equal to root x, then the function with regards to u is equal to all of that with regards to u. And the chain rule comes in very well here, d or du, you have inverse hyperbolic tangent u. And then du over dx, you have root x. This comes out as 1 over 1 minus u squared. This derivative of root x is 1 over 2 root x. You can marry these together and you'll have 2 root x. And then here you'll have 1 minus u was a root x. Root x squared is just an x. If you want, you can open this up. You'll have 1 over 2 root x minus 2x to the 3 over 2. Either of these answers will serve. This here is a good product rule question involving an inverse hyperbolic. You know the derivative of anything which is an inverse hyperbolic sign is 1 over root x squared plus 1. That's a template we can use when that comes into play. We have an f function and a g function, and we just use a product rule over here. You have the g function, which is the inverse hyperbolic, which happens to be a composite, times the derivative of the f function x squared plus x squared times the derivative of this inverse hyperbolic, which is again a composite. We have to do a chain rule over here for this part when the time comes. This comes out as a 2x, so we have a 2x inverse hyperbolic sine 2x plus we have an x squared, and let's do the chain rule over here. If u is equal to 2x, function with regards to u is inverse hyperbolic sine of that u. D over du inverse hyperbolic sine u, and then du over dx 2x. That's the chain rule completed. We'll take this forward. This stays as is, 2x inverse hyperbolic sine 2x. This comes out as a 2, which attaches with this x squared. You have a 2x squared. The derivative of this is something like this, except here we have u's in place. 1 over u squared plus 1. You have to resubstitute the u value over here, which is 2x. 2x will substitute right here. You have 2x inverse hyperbolic sine 2x plus 2x squared over 2x coming in place of this u is a 4x squared plus 1. And you can end with this right here, or you can do a common denominator, or if you want you can isolate a 2x from here, but we don't have to do all of that algebraic manipulation. This right here will take you to a good answer, and it's up to you if you want to do a common denominator here and take this even to a more simplified answer, but we can end this question here with this. We will end the video with this last question, not too hard. You have x inverse hyperbolic cosine x over 3. You know the derivative of this inverse hyperbolic cosine has a template 1 over square root of x squared minus 1, and you have to use that. Again, product rule. Here's my g function, here's the f function. You have the g function, which is a composite, multiplied by the derivative of the f function plus the f function times the derivative of what will be eventually the g function. We have to calculate that, for which the chain rule will come into play. The derivative of x is just 1, so this stays as is, cosine h minus 1 x over 3. Here we have to do a chain rule, and let's do it. If v is equal to x over 3, so d over dv, you have inverse hyperbolic cosine of this v. dv over dx is x over 3, which is not hard. This stays as is, inverse hyperbolic cosine x over 3 plus, we have the derivative of this to be 1 over root x squared minus 1, except here we'll say v squared minus 1 because v is our substituent, and x over 3 comes out as 1 over 3. Let's combine things. You have inverse hyperbolic cosine x over 3 plus x here in the numerator, you have 3 here in the denominator, and v can be resubstituted for x. V squared is an x over 3 square, which is an x squared over 9 minus 1. You could simplify all of this, and I will. Let's focus only on this part right here, and then we'll work it out, then we'll simplify this expression. We have 3 root, we have x squared minus 9 over 9. That's what this simplifies out to, which is really a 3 over 3 root x squared minus 9, which is really x squared minus 9. So everything here in the denominator simplifies to a root of x squared minus 9, and we can make that substitution, root of x squared minus 9, that's simplification, and we can say that this right here is our derivative. If you want, you can do a common denominator, I won't, and you can take this to the next step, but we can end it with this. So it's not a hard concept at all, these inverse hyperbolic derivatives. You know the inverse hyperbolic sign is this 1 over root 1 plus x squared. The inverse hyperbolic cosine is what you have right here, 1 over root x squared minus 1. Inverse hyperbolic tangent, the derivative of that is 1 over 1 minus x squared. These three are the most important derivatives you need to know for the inverse hyperbolics. And if you know those three, you should be confident and comfortable with this topic on inverse hyperbolic derivatives. Thank you for watching. Have a nice day.